Maria, shall we start our meeting or shall we wait a few more minutes?
Maybe just a minute or two more. We're getting several attendees coming in right now.
Okay.
Whenever you wish, sir.
Okay. So let's start. Welcome everyone. My name is Sabia Gan. I'm the chair of Application Interest Group, and it's a pleasure to welcome you to the first meeting. And we have a very interesting program outlined today. We have two speakers. And Maria, if you can move to the next slide. Before we start the meeting, I just want to remind you that this meeting is recorded, and if you do not want to be recorded, so you may want to mute your webcam and participate by chat function. If you have questions or comments, I would request you to raise your hand or leave your comments in the chat box, which you actually can find on the top of the screen. So you can leave your chat in the chat box. The way we will do we will conduct the program. We will have the speaker present their presentation, and then that will be around 25 to 30 minutes, and then we will we will take some questions. That's how it's going to work today. So Maria, we can move to the next. Yes, just to briefly introduce myself, I'm Sabia Gan. I'm actually a scientist, actually a group leader at EMPA in Switzerland. And unlike most of you, it's evening for us. So, but for you guys, it's morning. So good morning, everyone. I have been working at EMPA for 15 years now, and I'm actually a trained chemist, and my team is specialized in development of sustainable additives and polymers and coatings. It's a lot of stuff we do in my team. Today we are going to address a very important topic. If you look at these structures here, for people who are not aware of what PFAS are, PFAS are perfluoroalkyl substances, and it's actually a family of substances which are composed of carbon fluorine containing, I would say, bonds. And we all know that PFAS are everywhere in this in our world. I think the speakers are going to talk more about it. Just to give you an idea, some of the very common PFAS, some of them are which are banned, like the C8 PFOA and the C8 PFOS. They're quite banned now. Yeah, and we do have also, these are small molecules on the top, A and B. Perfluoropolymers are still being used quite a lot. You can find them in your food packaging. You can find them in utensils you cook food on. So they are everywhere, and they do have a lot of, they have created a lot of interest in the scientific community. And there are a lot of legislations looking into their potential toxic effect. The reason why they are very problematic is because they are persistent. The carbon fluorine bond is quite strong. So it stays forever, and they're also known as forever chemicals. So Maria, if you want to move to the next slide. So it is very interesting. I personally don't work on this topic, but I have heard a lot. It was we were thinking about putting together a program for all of you guys, and then suddenly, beginning of the year, I heard from Doruntine. She was actually the initiator for this program. I really thank Doruntine for approaching us on this topic. She works in EPA, so she's one of the speakers today. And then we thought, why not take PFAS as the topic for the first meeting? And then I know my colleague, Dr. Wang at Empa, so he's going to talk more about PFAS and the regulations here in Europe. So we have two speakers from two different parts of the world. From European side, we will have Dr. Wang speaking about PFAS, what are the restrictions, opportunities, and challenges, whereas Doruntine is going to more talk about the effluent related regulations of the PFAS in the US. To start with, we will start with Dr. Wang presenting first, because he requested it's late evening for us, so we want to be fresh to present, and so I accepted Dr. Wang's request. So Dr. Wang actually is my colleague from a different lab. He has been working at Empa since 1 year, I would say. Very recently joined Empa. He has a PhD in environmental science from ETH, I believe, and he is working in the lab technology and society. And his main interest is to understand life cycles of chemicals and how they affect the environment. He's also very interested in chemical management, so as to develop a sustainable circular economy. Without ado, I would like to invite Dr. Wang to present his talk. The presentation will be around 25 minutes, and I expect some questions towards the end, 10 to 15 minutes of questions. So Dr. Wang, please.
Yeah, many thanks, Tabia. Many thanks for the invite. And it is also my honor to present some of, I've been working on PFAS for the past 15 years. So I'm happy to share some of the lessons that I've learned, and also some of the recent developments in the EU. So my talk is about forthcoming REACH restriction on PFAS, and so the challenges and opportunities. Here's my outlines. I will give a brief introduction about what are PFAS and why are PFAS problematic. I understand this group is also works a lot on the textile issues. Therefore, I will also dive a little bit more deeper into the PFAS use in textiles and some concrete problems. And then go into the PFAS restriction regulations in the EU, and then the current ongoing regulatory process on the restriction of the broad class of PFAS, and then give some thoughts on the essential use concepts. So what are PFAS, as Sabir said? So PFAS are a group so-called per and polyfluoroalkyl substances, and recently in 2021, the OECD has published a new report and provided a revised PFAS definition, stating like they contain at least one fully fluorinated methyl or methylene carbon atom without any hydrogen, chlorine, bromine, and iodine atom attached to it. So as also Sabia said before, that PFAS is a very broad group of substances with both polymers and non-polymeric ones. Here's kind of like in 2011, there was already one definition proposed by Buck et al. And including PFOS, PFOA, and like also different hydrofluorocarbons or the perfluorocarbons and the polymers PTFE, perfluoropolyethers, and cyclohexafluorinated polymers. And then what's happened with the new OECD definition is that it also further includes those chemicals that have functional groups on both ends of the fluorinated chains, or like has a kind of a cyclic ring, and all those have the kind of aromatic ring somewhere in the functional group. So this becomes a bit more broader and more inclusive. And why are PFAS problematic, and why do we care so much about them? It is also, as Sabia just also introduced, that almost all PFAS are highly persistent, and many are bioaccumulative, and many of them, if not all, can cause some sort of adverse effects on human health or the environment. And many have been detected ubiquitously. And why is this very important and concerning? This is because when we look at, because they are very high persistency, and the combination of the high persistence and the ability of nearly all of them can cause some sort of adverse effects is really concerning, and it's not a very good combination. Because when we look at risk, as many of you may know, that risk is combining both the effects what chemicals can cause on humans or on the environment, and and with the exposure, like how the humans and the environment are being exposed to it. So, and if we plot it into a kind of figure, and if we use the y-axis as a risk, x-axis as exposure, because these chemicals, PFAS, are so persistent, and if we just keep producing and release them, and so will also the exposure levels go higher and higher, and at some point it will cross the safety level and thus cause a risk. And more importantly, because of this high persistence, by the time that it crosses the safety levels, there's not much can be done. That's one major issues. And I also like to highlight about the safety thresholds, which is also a factor that with a lot of uncertainty. So over the time, we have been studying PFAS and their adverse effects for, like, I would say, like nearly 3 decades. And what has been happening is that our understanding of these compounds are getting better and better, and the safety level is also getting lower and lower. So here's kind of the time about safety levels in drinking water set in the US. And you can see that in the early times, like early 2000s, the levels was kind of at 100,000 or 10,000 to 100,000 per nanogram per liter, but it has been like significantly lowered within the last like 15, 20 years. And most recently, like a couple of weeks ago, the EPA has proposed legally enforceable levels of in drinking water, and it is 4 nanogram per liter. So the levels has gone from like up to like 100,000 nanogram per liter to 4 nanogram per liter, and this has also taken into account the analytical abilities of measuring such substances. So what we know is that like the exposure is getting higher and higher, and the safety levels is getting lower and lower. So at some point, they will cross the safety level. So many have called to manage PFAS as a class. So there have been a couple of papers by the scientific community in the past couple of years. So PFAS have been widely used in the textiles. So here I find a very interesting figure in one of the papers. It kind of shows that there are these perfluoroalkyl acids, and then the precursors to the perfluoroalkyl acids. These are mostly the non-polymeric substances, but also there are some polymeric substances, and many of them are like relevant for the textiles. I use different colors here because it's mainly in the textiles mainly use this so-called side chain fluorinated polymers to coat the outdoor jackets, and then such side chain fluorinated polymers may contain this the PFAS impurities. In addition, that's also textiles like, for example, in the Gore-Tex have used the so-called fluoropolymers as the membrane, and there's also that's like in the manufacturing processes, also for the machineries, that perfluoropolyethers have been used as lubricants or like heat transfer liquids. So there are a lot of different PFAS are being used in the textile industry, and mainly talking about the fluoropolymers and precursors to PFAS and also the PFAS. So there have been a lot of studies about the PFAS use in the textiles, and also showing that so this PFAS are being used for different types of products, like with different performance requirements, particularly like in the outdoor apparels, marine garments, and more these professional textiles. As shown here, here's also kind of a figure on the right side, just to show how the PFAS are being used in the textile products. So if we look at this kind of, it's a very simplified view, that if the textiles may have a PTFE or Gore-Tex membrane in the middle, and then on the outside it may be coated using the side chain fluorinated polymers. And then because of these constructions, they're related to a couple of issues. For example, as said before, that the side chain fluorinated polymers may contain different non-polymeric PFAS as impurities, and they're not chemically bonded to the side chain fluorinated polymers, and therefore they may be released during the use, and the kind of also the final disposal. So there have been studies showing that like they both already measured both volatile ones and also the non-volatile ones, like in the different textiles, and including like there was a really hot paper last year about the firefighters exposure routes via the PFAS in their professional textiles. Second is that all the side chain fluorinated polymers, they're not always like they themselves may be released during the use, during operation, during the washing, and there have been these studies showing that when when washing the outdoor jackets may create a lot of these micro, like may kind of break the side chain fluorinated polymers, and then form the different degradation products in the environment. Then also that the textile itself maybe break with this very hot topic of the microplastic fibers, and then there will also sort of side chain fluorinated polymers maybe just released along with the microplastic fibers and get into the environment, further degraded. So this is also major issues like in the use phase. And then there's this is the middle, the Gore-Tex or these membrane layers. It also has a lot of issues. It may not necessarily be as problematic as the side chain fluorinated polymers during the use phase, but in order to produce the Gore-Tex or other these membranes, a lot of these processing aids may be used, and also there might be a kind of a disposal could be kind of create some of the issues. So therefore, that the fluoropolymers can also create a lot of troubles along their life cycle. Therefore, that there have been a lot of the actions on the PFAS within the EU, particularly like there have been 4 restrictions set in place, like back in 2006, the EU already regulated or restricted PFAS and its related compounds, and then about 15 years later, also passed through the restriction on PFOA, its salts and the related compounds. And then since last 2 years ago, the 6,2,2-fluorotelomere which is also kind of used to treat certain products on the surface, have also been restricted. And then early this year, there was further like the perfluorocarboxylic acids, kind of the longer chain homologs of PFOA, and their salts and also related compounds are also restricted within the EU. In addition to that, there have been also other PFAS identified as substances of very high concern in the EU. So these substances are not restricted, but if the products contain more than 0.1% of these compounds, the manufacturers actually have the obligations to report that. So the consumers are aware of that. Their products, such products can contain more than 0.1% of this substance of very high concern. And this including this HFPODA, which is a kind of a processing aid used by chemicals and some other companies to produce the PTFE. And then there's PFBS and salts. This could be kind of the degradation products of some these textile finishes. No, and what is more, and then there are also a couple of these restrictions that currently under evaluation and the preparation. So 2, like the PFHXS, which is the shorter chain homologs to PFOS, and then this PFHXA, which is the short chain homolog to PFOA. They are also have been proposed for the restriction in the EU, and the European Chemicals Agency's scientific bodies, the Risk Assessment Committee and the Social Economic Assessment Committee have provided their opinions. Now we're basically waiting for the European Commission to decide on the final restriction, how it may look like. And then there also have been 2 proposals recently submitted. I think one is kind of to the end of last year, that there was a kind of a proposal about to restrict the whole class of PFAS in firefighting foams. And then early this year, in January, Germany, on behalf of 5 European Union member states and other countries, to have already also submitted a much broader restriction of the whole class of PFAS in other uses, also in like other uses other than the firefighting foams, also including in textiles. So it is a little bit, the proposal is a little bit complicated. Here we're just, it's about 2,000 pages long, and here I just show you some of the main considerations or the main proposal text. That's so here kind of first is that the restriction provide a very concrete scope of the restriction. It talks about the for the inclusion, it used the OECD definition. Says any substance that contains at least one fully fluorinated methyl or methylene carbon atom without any hydrogen, chlorine, bromine, and iodine attached to it. And meantime, it also excludes some very specific PFAS, like for example, those which has oxygen connected to one single kind of CF, like a fluorinated carbon. The reason is, or the argument is that in these cases, because of the presence of heteroatoms such as oxygen or nitrogen or sulfur, the degradation products will not form, like the compounds can be fully mineralized, although it does not necessarily mean they're not persistent in the environment, but they're not as persistent as other PFAS. Therefore, in the proposals, they have been suggested to be excluded from the restriction. The restriction is basically saying that at certain, after the agreed time, all the PFAS should not be manufactured, used, or placed on the market. And then like either on their own or as like in another substances or in a mixture, or and it has also provided some kind of the concentration threshold. So if it is below this concentration threshold, then the product will not have any issues. But if it is above these proposed levels, then the product can also not be put on the European market. So it is also quite complex because it is, according to the restriction proposal, it will kind of regulate about 10,000 different PFASs, and it is very difficult to measure them all one by one. Therefore, it provides quite several different ways to measure the compliance of the products. First is it is proposed if you use a targeted PFAS analysis, and then the levels of any PFAS should be below 25 ppb, parts per billion. And then if we're looking at still, if we use the targeted PFAS analysis, but it's like a group of maybe measure more than 20, then the overall, like the sum of these 20 should not be beyond 250 ppb parts per billion. And then there was also the cases, because these are the target analysis, it's very complex, very more energy and more consuming, resource consuming. And then they also proposed a kind of total fluorine approach. So this approach also included the polymeric PFAS. That it's using such total fluorine approach, it should not be more than 50 ppm, like parts per million. Sorry. And it says that if the total fluorine exceeds 50 milligram fluorine per kilogram, the products, and then the manufacturers, importer, or downstream users should, upon request, provide to the enforcement authorities proof for the fluorine measured as content of either PFAS or non-PFAS. The restriction proposal also have included several derogations, which means kind of exempted, these derogations exempted from the restriction based on kind of the specified the conditions. For example, like there are 4, it was kind of by the proponent, they proposed like at least 4 such derogations. Is like mostly related to the use of PFAS in personal protective equipment and also the after treatment. And also there's also the textiles for the use in filtrations and separation media used in high performance air and liquid applications in industrial or professional settings. So they also have the kind of the year needed like allowed for these such exceptions, and in addition, additionally they have kind of some textile uses proposed but not agreed to propose as exemptions. So all this, the next step is that now the proposal has been made available on the ECHA website since 7th February 2023, and then it will start a very long kind of on open consultations, and then the ECHA's risk assessment and risk socioeconomic assessment committees will evaluate the proposals and also the information collected during the open consultation, and then make recommendations to the European Commission, which will then be and then the European Commission will be decided the final restriction based on the opinions from the ECHA. And this is probably will take place within the next 1 year or 2. And of course, it proposed a lot of the kind of forced a lot of the industry to make transitions. And it's not always easy. So, but like the scientific community has been thinking about these problems. How can we move forward? So the idea it was kind of to introduce the essential use concept. Essentially, this is to understand how chemicals are being used in products. There are some papers published, and it was originally used in the Montreal Protocol. And you can see like I suppose my presentation will be available later on, and you can see all the details. The idea is that the essential use concept will divide it into 3 categories. Down is the non-essential use. So this is the use of the chemicals that does not have a function necessary for health, safety, or the functioning of society. So they can be directly phased out. There's also substitutable uses. So they do have an important use, but such a functioning can be replaced by other alternatives. So then they can be replaced. And then there's the essential use. They have very important functions, and there's no suitable alternatives. And when we look at the textiles, we can see because based on the performance requirements, they can be divided into these 3 groups. The group 1 is kind of non-essential uses for like the leisure outerwear, because they're having some kind of the skin footwear. They said they could eliminate nearly 70% of the PFAS without making any changes, and they just don't need use in kind of 70% of their products. And then the second category is more like for outdoor apparels or marine garments. Actually, this is mostly for the water repellency. And in such cases, they are substitutable right now. I'm also showing some examples that this fluorinated polymer, like fluorinated chemicals producers, PFAS producers themselves have already produced the non-fluorinated textile finishes for water repellency. This is done by the DuPont. Now it's the Chemours. And then the third category is with much higher performance requirements. Then there is true innovation is really needed right now. So overall, the take-home messages would be that PFAS have been used in many textiles, but they are problematic due to the high persistence and other hazardous properties. PFAS are released during production, use, and disposal of textiles, causing environmental and human exposure. More strict regulations on the class of PFAS in the EU can be expected in the near future. And one way to comply might be to use the essential use concept to expedite sound management of PFAS and guiding innovation, including in textiles. So thank you so much for your attention, and the questions and inputs are most welcome. Thank you so much.
Thank you, Dr. Wang. It was a very interesting overview of PFAS, where they're used and what are the perspectives from European standpoint. We do have some questions. If I look at the chat, I also welcome if there are other questions. The first question is from Mustafa. I think he's asking, I am wondering if there is any presentation slides with the discussion. I believe you are asking if these slides are going to be available later on. Maria, can you please confirm, are we going to put the slides also later on for the attendees to access?
If Dr. Wang and Doruntine share them with me, I'll be happy to share them with the in the library of the communities, the chemical applications interest group community, and share it with the registrants. Yes.
Okay. We do have another question from Mike Quante. He's asking, what does AFFS stand for?
Yeah, I think it will be the AFFF. So this Aquarius fire fighting foams. Yeah, or I think it's also the Aquarius firefighting foams. So these are kind of the foams to treat Class B fires.
Okay. What are the chemicals which are included in this AFFS?
So these are mainly the cyclin fluorinated polymers are used, or the 622 fluorotelomere based some FTAB some alkyl batings are used. Yeah.
Okay. Are there any other questions from the audience? I do have a question, Dr. Wang. There's a lot of studies which are now available on the toxicity of these PFAS. Are there studies, probably most of these studies are targeting individual compounds, I would say, or individual class of chemical. Are there studies which are also targeting combination of these PFAS and what do you call a synergistic or antagonistic toxicity assessment of combinations? Because in the nature you find them all together, I would say, huh?
Yes, I think so far such studies have been relatively rare. I know there have been some studies about these competitive bindings to the steroid receptors, but there's there are not so many these studies available right now.
Okay. There was another question I had. I'm not sure if I followed these PFHS and PFHA. Can you differentiate the structure from the PFOAs and PFOS?
Yes. So the PFOA is the C7, like a 7 fluorinated carbon plus 1 carboxylic acid group. And the PFHXA will be its shorter chain homolog with 5 fluorinated carbon plus 1 carboxylic acid group. And then for the PFOS, it said they have 8 fluorinated carbon plus 1 sulfonate group. And PFHXS is the C6 short homologs. So it's the 6 fully fluorinated carbon plus 1 sulfonate group.
Okay. I do see another question. Well, there's one appreciation. Thank you for an excellent presentation. And then there is a specific question. Dr. Wang, thank you. Do you see the issue of microfiber pollution accelerating regulation around essential use of chemical compounds like PFAS in textiles?
I think this I think it's maybe the PFAS regulations are going a little bit faster than the microfiber pollution. So I think the people also the regulators concerned a bit more right now about the PFAS directly. I know that in the EU they're working on some policies about reducing the microfiber pollution, but I think the policy document has not been available yet.
And then there is a second part of the question. Do you know of any other studies in progress about the impacts of PFAS treated fiber fragments that are released in the life cycle of making or using textile products?
I think yes. I will say that there have been no studies, or I haven't heard about any studies about this fiber fragmentation during the making process. I've heard another group is working on the use phase, kind of the release during the use phase. I think some studies will also be published soon again.
There is a question, I'm not sure if I get it. I believe the attendee is asking, does the length of these PFAs have any effect on how they enter the body?
Sorry, can you say it again?
So the length of these PFAs have any effect on entering the body, human body, I believe, or microorganisms?
Yeah.
Because
so the
yeah, please go ahead. Yeah.
So I think I think it's the PFAS. I think there have been some studies showing some of these because they're surfactants, so they have quite surfactants activities, and then can kind of interfere the kind of the long kind of the I have to say I'm not a toxicologist, but I just read that they can interfere with the kind of the extracellular materials, and then kind of so make the long cells doesn't work.
Okay, so the length of these chains do have a big influence how they interact with the body, huh? So there are some studies. Okay.
Yes.
And then there is another question. If there are any PFAS or similar compound analysis in microfibers in water or wastewater?
I think not right now. It's not the. I think there's still some issues with the measuring the microfibers in the water, and then you need to do more PFAS analysis will be even more difficult.
Okay. I believe the same person, the one earlier, is asking if these PFAs can be I mean, inhaled through breathing, or can be taken through skin into our bodies?
Yeah, both exposure pathways are possible. So for the skin, I think there's not so much studies available yet, but I know that in CTEC, the Society of Environmental Toxicology and Chemistry, I think I've seen some the presentations. So some studies will come soon.
Okay. Seems like we are at the end of all our questions. I will still leave a few more seconds if you have more questions. Dr. Wang there's one more question. So PPE heat accelerate process. So I'm not sure I understand the question. Maybe the person can ask this question directly, so they can open the mic and then ask the question.
Yes, of course. Thank you, Dr. Wang. My name is Avi. I'm just asking about the use of these molecules and the risk, because as I understand, because I'm using them, the upper the end item apparatus, and then as I understand, they are lining in the second layer of the materials of the textile, and it's very thin layer of the textiles. And PPE suit, when the firefighter is entering the burning building, it's very hot. So yeah. Does the heat accelerate the risk of the exposure of this molecule?
Yeah, I would say that like the heat will definitely accelerate those volatile compounds to be released from the material.
What temperatures is there a work, a study of what kind of temperature it causes, and what kind of apparel are using?
Well, I think there have been no studies about this, like really to measure it. But generally, like the volatile compounds can be always slowly released, and then with higher temperature, it will accelerate the release speed. But I believe nobody has really to study the. But I think maybe theoretically might be possible to calculate. And then yeah.
Okay, thank you.
So I think we have already taken quite a lot of time. It was an excellent presentation. I got to learn a lot, I would say. I believe everyone else has. There were a lot of questions. So Dr. Wang, I thank you again for your presentation and all the information regarding PFAS and how Europe is handling PFAS. The presentation is recorded and it will be available to the community. I believe the presentation is also going to be the slides are also going to be available. I'm not sure, Dr. Wang, if you would take some questions later on. If people have any specific questions, they can also email you about
sure.
Yes. So he's also available to answer some of your questions. So I really, I would say, encourage people to ask questions through emails as well. So again, thank you, Dr. Wang. We will see each other soon. We are at Empa. So yeah, thank you again for your kind presentation. We move to the next presentation. It's going to be from Ms. Doruntine Rexhepi. I hope I pronounce your name properly. She's an environmental engineer. Actually, she was the catalyst for this, I would say, meeting early in January. I think it was 2nd of January. You sent me an email suggesting us that the EPA has done some interesting study on PFAS. and she will be happy to share the information. So she was the catalyst for this meeting, and it's a pleasure to introduce Ms. Doruntine Rexhepi. She's an environmental engineer. She has a master's in environmental engineering as well as a bachelor's in environmental engineering from City University of New York. And she is currently working in EPA and dealing with industrial wastewater regulations. And recently they have done a very nice study on PFAS, and she's going to share some of the latest findings, which could then lead to discussions between different stakeholders. And that's probably what was the idea of why you approached us. So it's a pleasure to listen to your presentation. Please.
Thank you. Thank you so much, Dr. Gan. Thank you for having me. All right, let me just pull up my slides. Okay, just confirm that you're seeing my slides.
Yes, all good. Yep.
Excellent. All right. Well, thank you so much for having me here, and thank you to all of the participants that they're taking the time to listen to this presentation from EPA's Effluent Guidelines Program. I'm Doruntine, and I think this is a great segue to the background that Dr. Wang gave in terms of what are these, at least here in our program, we call PFAS. This is just a quick outline of the topics I'll be discussing today. So I'll start with an overview of the Effluent Guidelines Program, which we often refer to as just the ELG program, and our planning process. And this is important to show, especially how EPA has made some of its decisions regarding some of the PFAS work that I'll be discussing in a little bit. I'll dive into that initial PFAS discharge review that we've done for numerous industries. And then I'll go through, as part of the multi-industry PFAS study, I'll summarize EPA's data collection and findings on the textile mills point source category and some of the decisions that derive from those efforts. Then I'll dive into our latest publication of the Effluent Guidelines Program Plan 15, again, with a focus on providing some updates on the textile mills industry. And hopefully we'll have some time for discussions and questions at the end of this presentation. So before I dive into all of that, I want to take a step back and sort of, again, provide a little bit more introduction in terms of where does the Effluent Guidelines Program fit into this space of regulations for point source discharges. Again, we're only referring to the United States in this case. It seems like there's a broad audience that are here with us today. So anytime I'm referring to all of these legislations, it's in regards to the United States. So the Clean Water Act prohibits anybody from discharging pollutants through a point source into waters of the United States unless they have a National Pollutant Discharge Elimination System permit. This permit contains specific limits on which you can discharge. The limit will contain monitoring and reporting requirements of pollutants and other provisions to ensure that the discharge does not hurt the water quality or people's health. So as such, we must then understand where these permit limits come from. One way to get a permit limit is through receiving waters, and this is based on the water quality criteria and standards, and these are local limits that are usually set by individual states in the United States. Another way to get a permit limit is through technology-based approach. And this is through the effluent limitation guidelines, and these are national standards. And it's specifically these standards that our program develops. And we like to show these in two different boxes because they don't come together until, again, you're issuing that permit. And in sort of as part of the technology-based approach, and should there be an absence of a specific applicable effluent guidelines limitation, then permit writers must use best professional judgment, though these tend to be more site-specific. So when you're issuing a permit, this can be an individual permit for a single discharger. So in this case would be a single discharging textile mill facility, or a general permit for a broad group of similar facilities across a geographic area. An example of that would be stormwater. So permits must include the most stringent requirements based on either the water quality approach or the technology-based approach. So what are these effluent guidelines and pretreatment standards? They are national wastewater discharge standards that are set on an industry-by-industry basis, again, only within the United States. They're technology-based, and they are intended to present the greatest pollutant reductions that are economically achievable for an industry. And these are for sources that are directly discharging to surface waters, or indirectly to publicly owned treatment works, as we often call them as POTWs. EPA has promulgated ELGs for 59 industrial point source categories thus far. The Clean Water Act further requires that EPA must annually review all of these existing effluent guidelines and pretreatment standards to determine whether or not revisions are warranted. The Clean Water Act, though, does not describe the specific activities that must be included as part of this review. And our current process has evolved over the years by incorporating feedback from the public, our stakeholders, on how to best conduct these reviews. And we publish the results of these reviews in what we call the Effluent Guidelines Program Plan. The Effluent Guidelines Program Plan is a communication tool that EPA uses to, again, rely the results of our annual review and any of decisions we've made on any new rulemakings to revise any of the ELGs. In addition, the program plans also include updates on all of our current work that we're doing within the ELG program. The Clean Water Act also directs EPA to publish a plan every 2 years to share the results of the review with the public and to establish a schedule for any effluent guidelines revision that has been identified. And also identify any industries that are not currently subject to effluent guidelines that may discharge non-trivial amounts of toxins, and also establish a schedule to take final action of that. So to fulfill this requirement, EPA has implemented a 2-year publication cycle for the ELG program plan, where year 1, we publish a preliminary ELG program plan, which again, this includes the results of the most recent annual review of all of our existing effluent guidelines, announcements of any new studies or rulemakings we've undertaken, and updates on all of our existing work, including studies and rulemaking. And what's different for the preliminary ELG program plan is that we solicit public input on the content of this plan. Whereas for year 2, then we publish an ELG program plan, which again, similar to the preliminary, includes the feedback, a summary of the feedback we received on the preliminary plan. It includes also documents on how we responded to the public input we received. Again, the results of the most recent annual review, announcements, and updates on all of our existing work. So this illustration gives an overview of our current planning process and how we conduct these reviews of our existing effluent guidelines. Initially, we start with a screening level analysis of all the point source categories or industries. And what this does, it gives us the mechanism to prioritize categories that warrant further investigation. And as I mentioned, this analysis has evolved over the years in terms of how we rank all of our point source categories. So from this screening level review, we then conduct a more preliminary review of the top ranking point source categories from that initial analysis, using readily available public information we're able to find. And if we do not have enough information to support a decision and again, the decision being whether or not revisions of that particular effluent guidelines is warranted. Then we conduct a more in-depth review, which is what we often refer to as detailed studies. And as part of the detailed study, we often collect primary data. And again, based on the information and the data, we were able to collect as part of that detailed study, then we make the decision whether or not ELG revisions are required for the industry specifically studied. And all of these findings and decisions are presented in the ELG program plan. Again, this illustration just shows what that cycle of the ELG planning process and review looks like. As I mentioned, we often meet with different stakeholders, with different trade associations. We meet with local and state governments to get additional information, recommendations, a specific pollutant of concern, a specific industry of concern. Then we do a screening level analysis of the pollutant discharges by the point source categories. We prepare the reports. We publish that preliminary plan to identify categories that we want to study a little bit further. We collect public input. We perform additional investigations. We conduct additional outreach with our stakeholders. And then we decide which categories to identify and which not for any potential guidelines revisions or even new guidelines. And then we issue that final plan. And that just goes in a circle. So whether we're conducting a screening level analysis of our existing effluent guidelines, or we're conducting a detailed study, or if we're doing a rulemaking, these are some of the major elements of information we collect. Again, depending on specifically at what phase we are in. Obviously, for a rulemaking, we collect a lot more information versus that preliminary category review. And this includes collecting data that are publicly available. We do technical and financial surveys of industries. We visit and observe. We often do site visits and observe the production process and the wastewater treatment systems that industries have in place. We do wastewater sampling, and specifically our program also drafts Clean Water Act analytical methods that I'll dive into a little bit later. And we meet with stakeholders that may have additional data and information to share with us. We do technology assessments where we look at the wastewater characterization, the technology performance, the feasibility, the cost to install new technology and process changes. Again, these being technology-based effluent guidelines standards. We also do economic analysis where we look at the economic achievability. We do value of environmental and human health benefits. And of course, we do environmental assessment. Now let's dive into that initial PFAS discharge review. I think it was great that Dr. Wang was able to present exactly what these PFAS are, which I didn't really get into particularly for this presentation, but you already have the information to know that some of these specific PFAS are toxic on to human health. And as part of that, I also want to say, while this is just scratching the surface of the effluent guidelines program plan, there's numerous PFAS efforts that are going on within EPA. And should you need more information after I'm done presenting, I will share a link with you to the EPA's PFAS strategic roadmap that outlines all of the different offices and the work they're doing to address PFAS. So as part of the statutory requirements, as part of our planning process, as I described earlier, we examined the Office of Water examined readily available information about PFAS discharges. Again, this was just in general. And in 2009, we published our findings in the EPA's review of PFAS in industrial wastewater discharge, alongside the preliminary ELG program Plan 15. And at the time, we determined that further data and collection and study were necessary to inform decisions on how to best address industrial PFAS discharges. At that time, we then announced the multi-industry PFAS study. We also announced landfills PFAS preliminary review. So the multi-industry PFAS study focused on continuing, again, collecting data and review of PFAS manufacture, the use of PFAS, control, and discharge by 5 specific categories that EPA determined were likely to be discharging PFAS in their wastewater in that preliminary review. The objectives of the study were that we examined specific industrial categories manufacturing or using PFAS. We identified specific facilities discharging PFAS in their wastewater. We collected, compiled, and reviewed information on PFAS and discharges. We determined the types and concentration of PFAS in wastewater discharges. We also assessed the availability of technologies capable of reducing or eliminating PFAS in wastewater discharges. So in September 2021, we published our preliminary reports of our findings from the multi-industry PFAS study. And again, that report discusses the information and data we've collected and reviewed on the use, discharge of PFAS on 5 industries. So the industries that we looked at were organic chemicals, plastics, and synthetic fibers. And this is where PFAS manufacturers fall under. We also looked at metal finishing. We looked at the pulp and paperboard industry. We looked at textile mills industry, and we looked at commercial airports. I also want to note that we acknowledge that additional industrial categories use and potentially discharge PFAS, though at the time of the study, we prioritized the review of these based on information and data collected during that initial review of the data. Again, some of the sources that we were able to collect data and information from were our own EPA data sources. This was looking at the discharge monitoring reports, the chemical data reporting, Toxic Substance Control Act, and inventory. We've also looked at the Industrial Wastewater Treatment Technology Database and the Drinking Water Treatability Database. We met with other federal partners, such as the Federal Aviation Administration, Food and Drug Administration. We looked at wastewater permits, applications, and fact sheets. We've done numerous outreach data through local and state authorities, our regions. We've met with trade associations for pulp and paper, metal finishing, and for PFAS manufacturers. We've met with companies that either manufacture or formulate PFAS. We've attended conferences and webinars, and we did a heavy literature review. So again, while we looked at other categories, for the purpose of this meeting, I will be mainly focusing on textile mills from the findings that were our preliminary findings at the time of the publication for the multi-industry PFAS study. So as you all already know, textile mills receive and prepare fibers. They transform fibers into yarn, thread, or webbing. They convert yarn and webbing into fabrics or related products, or finish these materials. Many facilities produce a final consumer product, while the rest produce an intermediate product for use by other establishments in the industry. So we know that PFAS have been applied in a wide range of textiles, including and are not limited to clothing, footwear, carpets and rugs, household fabrics, upholstery, medical garments, firefighting gear, luggage, and outdoor gear, as previously demonstrated by Dr. Wang. So EPA found, and again, this is mainly to EPA found that during the fabric and carpet manufacturing, PFAS can either be incorporated as an additive mixed into the individual fibers, or they can be sprayed on as a coating onto finished fabrics during the manufacturing or after sale. And again, this is to provide products with water, oil, soil, or heat resistance to improve the cleanability of oil or water-based stains, to be used as a wetting or anti-foaming agent in dyeing and bleaching. Again, also to sort of provide that breathing moisture barrier to wind and rain in outdoor gear. Again, just want to sort of specify that these were our findings at the time of the publication. Again, at the time of the multi-industry PFAS study, EPA did not receive any information or data directly from the textile mills industry. We did not have information to identify specific facilities that were using PFAS. And what we were able to determine, though, is that the majority of textile mills are concentrated in southeastern part of the U.S. So our review of PFAS for the textile mills industry is largely based on public information and literature that we were able to gather. Though we were able to gather some wastewater data from states sort of doing source identification, and we were able to document the presence of PFOA and PFAS in discharges. And at the time of the publication, we had limited concentration data on other discharges by the industry itself. We weren't able to find any control for these substances, so we weren't able to find a final permit that includes any monitoring or control requirements, and we did not have any information sort of specifically for any specific textile mill facility. While I briefly sort of just gone through our findings from the textile mills, I think it's also important just to take a step back and discuss some of the other announcements that resulted from the multi-industry PFAS study from other categories that I mentioned we reviewed. So as part of our findings from the PFAS manufacturers industry, we have initiated a rulemaking to revise the limitations for the OCPSF category, again, to address PFAS discharge from those manufacturing PFAS. We've initiated a rulemaking to revise the metal finishing and electroplating ELG, again, to address PFAS discharge from these operations. We have, at that time, we announced a detailed study of PFAS discharge from landfills and textile mills, because again, we just didn't have enough information to make a decision at that time. And we also continue to monitor the reduction of PFAS use and discharge by the pulp and paper facilities and commercial airports through our planning process. Then it brings us to sort of the current updates. And most recently, we published ELG Program Plan 15. This was early in 2023. And Plan 15 presents, again, our findings of our annual review. It gives a summary of all the public comments we received and how we've addressed those, and announces new rulemakings and studies while sort of providing additional existing rules, updates on our existing rulemakings and studies. Again, for the purpose of this meeting, my focus was only PFAS in textile mills, meaning that we are doing, we have numerous other efforts, including PFAS and non-PFAS work going on at this time. So again, since September 2021, where we published our preliminary findings from the multi-industry PFAS study, EPA has collected additional data on PFAS use and discharge from textile mills. And this was through technical literature, textile manufacturing companies. We've spoken to our regions and state and local wastewater regulatory authorities, where again, they were able to collect additional data since the publication of the multi-industry PFAS study. However, the information that we've collected was very limited, which is why EPA made the announcement to expand the scope of the existing textile mills detailed study to include collecting data on PFAS and discharge through a mandatory survey from this industry. As I mentioned earlier, in addition to drafting effluent guidelines and pretreatment standards, our office works on also drafting Clean Water Act analytical methods. So right now we're working on 2 PFAS methods. Draft method 1633. This is a method to test for 40 PFAS compounds in numerous matrices, including wastewater, surface water, groundwater, soil, biosolids, sediments, landfill leachate, and fish tissue. We've published the 3rd revision of this draft method that contains quality criteria that are generated from the multi-laboratory validation study for wastewater. And while this method is not promulgated fully as part of the Clean Water Act compliance, we are encouraging stakeholders to use it and recommend it specifically for individual permits. We're also working on draft method 1621, which is for absorbable organic fluorine. This is currently a single lab validated method to screen for organofluorines in wastewater and surface waters through combustion ion chromatography. And we're currently working on multi-laboratory validating this method. And should you have any specific questions on these 2 methods, I encourage you to visit the frequently asked page. And should you have any specific questions on this method, I'll try to answer them the best I can. It's usually our chemists that work on these 2 specific methods. So now I'll open it up sort of for discussion and question. As Dr. Gan explained earlier, our initial, the idea of why we sort of reached out to this association was trying to get sort of a better understanding, better information in terms of where is the textile study, your member companies, or in terms of their potential use, any potential discharge, there's any legacies issues associated, and if whether or not sort of member companies have been collecting data, again, with a focus in the United States.
Thank you, Doruntine. It was an excellent overview of how EPA handles, I would say, effluents and the challenges you face in putting together these regulations. So it was quite interesting, I would say. It's a lot of information, I believe, for people, and for me, it's actually first time, and I'm not sure if I will ever be able to use it in Europe, but it's really interesting to know how challenging it is to get together a regulation. There are a few questions I see. If I would read the first one from Greg Woodcock. If a current municipal drinking water system is testing for PFOA and PFOS and has identifies levels greater than proposed EPA limits, what can be done by the water system to reduce PFOA, PFOS content in the water distributed to consumers?
That's a great question. While that is sort of a more specific question within Office of Water, specifically the Office of Drinking Water and Groundwater that may deal with that particular question, I just know that from general knowledge that we already determined there's existing technology that's able to reduce the pollution of these chemicals. So while the chemistry or sort of the chain length of these chemicals is different, which means that different technologies sort of are able to reduce them depending on that chain length. And I can point you to, again, the different databases that we have that talk about the specific treatment technologies that can be used within these facilities to reduce that pollution. And something like carbonated, granular activated carbon, reverse osmosis, ion exchange. These are some of the technologies that are able to, that you can use to reduce that. But again, depending on the targeted PFAS you're trying to reduce.
Very good. So I think there's another question which is related. Does the EPA plan to develop test methods specifically for filtration of PFAS, contaminated water, removal efficiency, etc., anytime soon. That's from Gilbert Morgan Linné.
Can you elaborate a little bit on that? Is it sort of, again, are you just referring to the wastewater aspect, the removal efficiency, meaning you know sort of the concentration of PFAS coming into your facility versus what's going out? Again, what our program does is just, you know, looking at those specific 40 PFAS chemicals. Using that methodology, you're able to determine what is the concentration of those 40 analytes that we have as part of the draft method 1633 versus the method draft 1621. Again, what that does is just sort of a screening level for organofluorines, meaning that initially you're able just to see whether or not you have fluorine in your wastewater. And then if you're looking for specific concentrations, then I would encourage you to use the draft method 1633 to specify the PFAS chemical of interest, and if you sort of the concentration, if you would like to know that.
Gilbert, would you like to be more specific with your question? So,
if that didn't answer it, but you can also feel free to email me.
You.
Yeah. Yep. We're available, and like I said, while I was hoping to, while this was a great presentation, we're also looking for feedback as well, and information and data on this industry in terms of, you know, how is the textiles industry using PFAS? You know, is it a dry process? Is it a wet process? If it's a wet process, do you anticipate any discharge of these chemicals? If so, have you tested for them? Again, we'd be interested in that data. And what this does is just for us to collect this data, we needed to make a decision. Just because we collect the data doesn't necessarily mean that we're going to be sort of revising the textile mills ELG. But should the data show that the concentrations from this industry are high, then EPA may make that decision to revise the ELGs, which is why EPA announced that expansion of our detailed study to collect mandatory data, because we weren't able to get enough information. We weren't able to talk to the industry at all. We understand there's a huge change in sort of the use of these chemicals in textile mills, just as, again, Dr. Wang explained what's happening in Europe. It has already happened in the United States, specific state by state. So an example, what California has done is that they have banned PFAS use in textiles and carpet and rug. So should any of those products contain PFAS, you're not able to sell it in California. So we understand there's a phase out of these chemicals, but we want to understand the timeline again, and sort of, does it still present a big issue? And ultimately, there's also the issue of legacy issues, because these chemicals, you know, are hard to get rid of, but we also understand that they're everywhere. You know, does it present an issue with sort of long term? And again, we are very much available to set up another sort of private call with you all to have sort of this larger discussion, or if anyone can speak to that, again, not as part of this meeting, but we are more than available to meet with you all just so we can sort of understand better.
There is a question from Elizabeth Easter. So would you like to ask this question yourself? Because she raised her hand and I'm not sure if there is a question, so feel free. Elizabeth, you raised your hand, so do you have a specific question? So if not, then I move to the next person. There is, I believe there are
Yeah, I'll take this one from Edward Witt. I think it's an important one. Can you discuss the scope, audience, and timing of the anticipated mandatory survey, and who will receive the survey? So right now, because we weren't able to collect enough information and data to make a decision, the audience and the scope will be all of the textile mills industry. So we're currently working on sort of identifying specific companies and their facilities who will be receiving this survey. But that doesn't mean that, again, the survey can it will be with heavy focus on PFAS use and discharge. And in terms of timing, I can't speak to that right now. Ultimately, it's going to, as we announced as part of Program Plan 15, the sort of the timeline and pace for all of these efforts will be sort of a function of funding. But if you have any specific questions, feel free to reach out to me on my email.
So let's move to the next question. Doruntine, you want to read it yourself? Probably it's much easier for you. Yeah.
Sure. So, can a POTW incorporate proposed test or discharge limits before EPA completed rulemaking mill that has a permit for discharge to POTWs? So you may be aware that EPA, end of last year, EPA has issued NPDES, again, sort of that permit, NPDES, that permit guidance, specifically talking about, it's only a guidance, so it's not sort of a specific mandatory request that EPA has done, but what they've done is a guidance for all the permit writers and all of those that might have sort of pre-treatment programs in their state. Then they encourage that you put at least monitoring requirements on the industry. And in terms of just to look at what are, especially for POTW, to better understand who your customers are and if they are supplying sort of PFAS discharge directly to POTWs. With that being said, we're also working on another effort. It's called the POTW influence study, where we're hoping to get additional information from indirect dischargers that may be discharging PFAS to POTWs. So again, the purpose being that there's just not enough data from stakeholders, from sort of EPA itself, where we're going to sort of sample different industrial users to see, to again, determine whether or not revisions are needed or identify any other industry of concern.
There is this question from Greg. Are either draft methods 1633 or 1621 appropriate for analyzing textile products?
That's a better, our chemists might be in a better position to answer that, but I believe, especially for draft method 1633, it's only specific to like those 8 matrices, which again was wastewater, surface water, groundwater, soil, biosolids, sediments, landfill leachate, and fish tissue. Although I can, if you reach out to me, I can put you in contact with our chemists. Perhaps they might have additional information in terms of analyzing PFAS in textile products. I think that's a great question.
Okay, there's one more question. As an end user, what kind of certificate should I have?
I'm not sure what that's in regards to. Again, if remember, all of this that I discussed is within a United States. So if you have a textile mill, a company, facility, sort of, if you're in that realm, if you know you're using these chemicals, you're adding it to your process. If it's a wet process, it'll likely have discharge. We'd be interested to know that. So in terms of a certificate, I'm not sure, again, where that would, I'm not sure sort of that the question being asked. If you can elaborate,
I believe,
maybe?
I think he, I believe as an end user, you need a certificate that the material was produced in a proper way.
Either you have PFAS or not PFAS. As of right now, I don't believe that within the United States there is such a certificate. I think there's a lot of effort, sort of just general knowledge that companies are trying to sort of have these verifications that they're saying they do not have any of these PFAS as part of their textile products or other products for that matter, actually.
Doruntine, I have also a question. You mentioned that EPA had a very big study which involved 5 different types of industries. And I believe you collected a lot of samples, you analyzed. Do you have, can you disclose which of these type of industry had the most I would say PFAS being, released into the water?
Sure. So that's a great question. So all of this is public information, and I can point you to the specific website. I can provide you perhaps even the collection of the summary of data that we were able to collect on all of these different industries. But at the top of my head, I believe it was PFAS manufacturers that had sort of some of the highest levels of discharge. But again, which is why we've announced sort of revising that ELG to address those that are manufacturing PFAS, but also metal finishing had considerable concentrations as well.
Thank you. There is a very specific question. It's related to EU. I'm not sure if you will be able to answer it. Are there EU methods to identify targeted PFAS in textiles and leather? Most likely this question is for Dr. Wang. I would think so. So if Dr. Wang, if you are still there, if you could answer this question.
He's still signed in. I don't know if he's actually, yes, he is. Okay.
Yeah, so he mentions it's ISO 17681. So this answers the question very well. So it seems we do not have any more questions. I will wait a few more seconds. If people have no more questions, I would like to thank our both speakers for informing us about all the regulations, the efforts which are being done in Europe as well as in US in handling the EP, the PFAS and the pollution. So I also like to thank all the participants for, I would say, answering all the questions, asking the questions, and taking interest in participating in this meeting. I believe Maria has a few more information which she would like to share. I believe she's going to talk about it, this AATCC communities, which is probably quite new. Maria, would you like to talk about it?
Thank you, sir. Yeah, the recording of this meeting will be posted in the Chemical Applications Interest Group community in the new AATCC communities. The URL is right there, aatcc.connectedcommunity.org, I think. If that doesn't work, try .com. But you can log in with your AATCC user ID and password, and the Chemical Applications Interest Group should be one of your communities. If it is not, you can go into your member record and choose to receive information from Chemical Applications Interest Group, and then that should be one of your communities. If Dr. Wang and the other speaker will share their presentation slides with me, I will also post those in the community. It might take a day or two, but that information should be up there before next week. And I know I had several people ask me to remind everyone that the AATCC will be having an in-person PFAS conference coming up in Durham, North Carolina in July. Registration is open for that right now. That will be an all-day conference, 2-day conference with a lot more in-depth information about PFAS use and what to do going forward to, what do we have to do next? And of course, if people are intending to attend the AATCC annual conference, which this year is in Greenville, South Carolina this September. All these events are at aatcc.org/events. And as you know, there's a lot of webinars and digital labs available on the AATCC website, and you can subscribe to the events newsletter if you want to have notification about those. And if you have any questions that you need for AATCC staff to respond to, this is our contact information. It's also on the website. And thank you very much.
Maria, one
Dr.
more
Gant?
thing.
Yes.
I believe the attendees will receive a questionnaire about today's meeting, and
Yes.
we would really appreciate if you can give us the feedback. It's a very short survey. And if you have any more specific feedback, you can also send us an email. I'm very happy to answer your question and take your input and try to improve these online sessions as much as possible. And if there are more specific topics you would like to be discussed in this community, I'm more than happy to organize other events. So from my side, I really thank both the speakers again and all the attendees in participating in this meeting. It was a really a nice experience to learn about PFAS.
Thank you for reminding me, Dr. Gunn. I'm going to put that in the chat as well so that folks can take the survey right now if they wish to while it's on their mind.
Very good. So with that, we end our event. It's already 10 o'clock for us. Yes. Thank you again. Huh?
Thank you for having me.
Bye-bye.
Thank you.
Thank you.
Great job.